In this video I want to discuss difference equations, or as they're sometimes known, recurrence relations. The example I want to use is taken from this exam question. It is un plus 1 equals 2 un plus 3. Now un stands for terms of a sequence. And n is a natural number, of course. u1 is the first term, u2 is the second term, and so on. For this particular recurrence relation, u1 is 3, so n starts at 1. So we'll be looking at u1, u2, u3, etc. We'll be interested in generating a sequence. Now, unlike in previous videos, we could get Tn, the nth term, as a function of n. We use the letter Tn for the nth term. Here we're going to be using the letter un. Un is not given as a function of n in a difference equation. So for example, if we wanted to find out what the 50th term was, suppose we want to find u50. Well, we can't plug 50 into some function of n and get out an answer. In order to get u50, we need u49. Because if we let n equals 49, what we get is u50 equals 2 times u49 plus 3. So I'm just using this recurrence relation with n equals 49. So we get u49 plus 1, or u50, equals 2 times u49 plus 3. So if we know what u49 is, we can find u50. So if we know a given term in the sequence, we can find the subsequent term. Now we're given that u1 equals 3 for this difference equation. So if we want to find out what u2 is, we can let n equal 1. So if we let n equal 1 in this, we get u1 plus 1, which is u2, equals 2 times u1 plus 3. Since u1 is 3, we can plug that in, and we get out u2 equals 2 times 3 is 6 plus 3 is 9. If we want to find out what u3 is, we let n equal 2. So we get u2 plus 1, or u3, equals 2 times u2 plus 3, which is 2 times 9 plus 3, which is 18 plus 3, which is 21. So we can build up our sequence gradually. Here I've written out the first 3 terms of the sequence. And we can continue on doing that, continue on increasing n by 1. But so far we have no way of getting a term directly from n. We have to know the preceding term. Now, in part 1 we want to find u6, the 6th term. To do that, we let n equal 5. So if we let n equal 5, we get u5 plus 1, which is u6, which is what we're after. That's why we chose n equal to 5, equals 2 times u5 plus 3. Now u5 is actually given to us. u5 is 93. Okay, so our sequence is 3, 9, 21, 45, 93, and we're going to calculate u6. It's 2 times 93, that's 186 plus 3 is 189. We want to verify that u6 is equal to the sum of the first 6 terms of a geometric series with first term 3 and common ratio 2. The first term is called a is 3, the common ratio known as r is 2. So we can write out the first 6 terms of the geometric series. Here's a. To get the second term, we multiply a by r, which is 2. So 3 2s are 6, and then we keep multiplying by 2 to get subsequent terms. So I've written out the first 6 terms, and the sum of these terms is 189, which is indeed what we had to show. It's equal to u6. Given that for all k, uk is the sum of the first k terms of a geometric series with first term 3 and common ratio 2, find sigma k equals 1 to n of uk. So the uk that's being referred to here in question 2 satisfies this recurrence relation. So we can just replace n with k. We can just call it uk for the purpose of the notation that's being used here. So uk plus 1 will equal 2 times uk plus 3. Now how do we find sigma of uk? Well, we could start with this. Sum both sides of this. Now, as I explained in an earlier video, when we sum something like this, we can distribute sigma in through this expression. This 2 is a constant factor. It can be pulled outside sigma, and we can split this into two sums. As I explained in an earlier video also, the sum of a constant is just the constant times the number of terms. So when k is 1 we have 3, when k is 2 we have another 3, when k is 3 we have a 3. So we're summing n 3's. We're summing 3 from 1 to n. So n 3's is just 3n. So this is just a constant function. Constant function of k. Now we're interested in this. We want to calculate this. But look at the left hand side, this sum here. We start by subbing 1 in for k. We get u1 plus 1, which is u2. Then we increase k by 1, so we get k equals 2. We plug 2 in, and the second term is u3. The third term will be u4. We keep going until we get to k equals n. If we plug n in, we get the last term, which is un plus 1. So if un plus 1 is the last term, then the second last term must be un. Actually, this term here would be got by plugging n minus 1 in for k. We get n minus 1 plus 1, which is n. Now the thing that we're after, sigma uk, looks like this. We plug 1 in for k, we get u1, then 2 in, and so on. And the last term is un, so we're summing from u1 up to un. Now, how can we relate this term here, the left hand side of our equation, to sigma of uk? Well, if we take this thing here, sigma of uk, where k runs from 1 up to n, and subtract u1, subtract this first term, because we don't want u1 to appear. I want to put this minus sign well over here, because this is all one sum. We subtract just this term u1. If we subtract u1, we're beginning with u2, which is what we want. We want this to start at u2. But we want to end with un plus 1, so we want to add on an extra un plus 1. Okay, I hope that's clear. So to get the left-hand side, we can start with this, subtract u1, subtract out this term, and add on un plus 1. And then we have this here, the left-hand side. So now we can gather all the sigma uk's together. We have 2 of them on the right-hand side, we have 1 of them on the left-hand side. If I bring this one over to the right-hand side, I'll get 2 minus 1 sigma uk's, or just 1 sigma uk's. Over here I'll have minus u1 plus un plus 1. If I shift the plus 3n over, it becomes minus 3n. Okay, so this is it. This is sigma uk. Now we'll have to get all of this here in terms of n. We'll have to get u1 in terms of n, and we'll have to get un plus 1 in terms of n. Well, actually u1 is a number. u1 is 3. So plugging in here, we get minus 3n minus 3. For un plus 1, I've actually written down 2 un plus 3. It's just a little bit easier to work with. So I'm using the difference equation here. The 3's cancel out. So we're left with 2 un minus 3n. But what is un? We're given that un, or uk, is the sum of the first k terms of a geometric series. So un is the sum of the first n terms of a geometric series. The one whose first term is 3 and whose common ratio is 2. So it's 3 plus 6 plus 12 plus all the way up to the nth term. Now what is the nth term? Now we saw this already. Tn is ar to the power of n minus 1. So here it's going to be 3 times 2 to the power of n minus 1. Okay, this is the nth term of a geometric series. So what is this sum? Well, we saw in previous videos that the sum of the first n terms of a geometric series is a into 1 minus r to the power of n divided by 1 minus r. So a is 3 into 1 minus r, which is 2 to the power of n, divided by 1 minus r, 1 minus 2 is minus 1. Normally, Sn is used for the sum of the first n terms, but actually un is standing for the sum of the first terms here, so you might get confused by notation. It's not Sn, it's un. And we've n terms. Simplifying this, we get 3 over minus 1, which is minus 3. So we have minus 3 into 1 minus 2 to the power of n. We plug it in here for un. We have 2 times minus 3, which is minus 6, into 1 minus 2n. Then we have a minus 3n. I've multiplied minus 6 into this. Minus 6 by minus 2 to the n is plus 6 times 2 to the power of n. I've written the minus 3n term down next, and then minus 6. So this is our answer, but let's do a check. Let's remind ourselves of what sigma uk actually is. So, well, it's u1 plus u2 plus u3 up as far as un. What is u1? u1 is the sum of one term of a geometric series whose first term is 3 and common difference is 2. So that's just 3. u2 is the sum of the same geometric sequence whose first term is 3 and ratio is 2. So 2 3s are 6. u3 is the sum of the first 3 terms of the same geometric series. So the first term is 3, r is 2. So we have 3 plus 6 plus 12. That's u3. u4 then would be 3 plus 6 plus 12 plus 24, and so on. un would be the sum of the first n terms of that geometric series. We saw that the nth term is 3 times 2 to the power of n minus 1. Let's just see if this thing here works out, say for n equals 3. Sigma k equals 1 to 3 of uk. So that means we'd just be summing these 3 terms. We also have these 3 terms written down up here. They are 3 plus 9 plus 21. That's equal to 33. Now we should get this answer if we plug n equals 3 into this, because we're summing as far as n equals 3. We get 6 times 8 is 48, minus 3 times 3 is minus 9, and then minus 6, so we get 48 minus 9 is 39. 39 minus 6 is indeed 33. So it checks out for n equals 3, it checks out. So the chances are it's true for all other values of n.